This video is part 2 of a multi-part series on these old voltage regulators that were used on Kohler engines in the mid-60s. For best results, watch the videos in order. In the last video, I showed the different styles available. I showed the power supply that I use, and I demonstrated how I test one to see if it's working properly. Now I'm going to take a look at this old regulator. I don't know anything about it. First I'll do a complete test to see if I think it's worth working on. I have a voltmeter to check the voltage I'm putting to the regulator, and I have an ohm meter to see if the contacts are open or closed. I like to disable the auto ranging and use the lowest range. The positive from the power supply goes to the generator terminal. The negative from the power supply goes to the regulator frame ground. This braided wire is not very good, so I'm clamping to the frame. Turn on the power. I'll set my bottom power supply to 5 or 6 volts. For more information on the power supplies, watch the first video. Now I'll connect the ohm meter to the battery terminal and the generator terminal. I can't clamp this one on the generator screw, so I'll clamp on one of these rivets for that terminal. Wiggle it around so it makes good contact. Now I'll start turning up the voltage. Notice the ohm meter shows out of range, so those points are open. And it looks like I went up to 13.9 before the points closed. But they do work. Now I'll go back down, and they open at about 12.7 volts. Back up, and they close at 12.9. Going down, they open at 12.7. Back up, they close at 12.9. So that set of points is functionally okay. I'll take the voltage way down so the contacts relax and go back up again. And that time I got over 14 volts before it closed. So not very consistent, but they work. That proves the coil is electrically okay. That's really all I need to see out of that first coil. So I'll move to the second coil. For this test, I'll connect one ohm meter lead to the F terminal and the other ohm meter lead to the chassis ground. Now already I can tell a couple of things. This set of points is normally closed, so the ohm meter reading should be near 0, but it shows 66 ohms. That means the points are so corroded they're not making contact. On this second set of points, there's a resistor in the circuit. So when the points are open, or not making contact, the meter will show the resistance value of that big wire wound resistor on the bottom of the regulator. And that should be around 60 or 70 ohms. This reading of 66 ohms is probably showing that the resistor on the bottom is good. I'm going to turn up the voltage and see what happens. I won't go much over 16 volts. Don't want to damage anything. The resistance changed a bit, probably because the corrosion on the points was changed when the points opened and closed. I call that all good. If that resistance reading ever goes much above 70 ohms, That means the resistor on the bottom of the regulator is bad. So based on this test, I think the resistor is good and the points are dirty or corroded. I'm going to turn off the power and take the cover off. Well, that's pretty ugly. That's not white paint. Everything that's white in here is covered with corrosion. If I was going to use this one, I'd clean all that stuff out of there. But that's not what this is about. For this video, I'm just going to make it function properly. This gasket can come off. I usually remove these cardboard tubes so I don't bend them, but these are stuck on there, maybe rusted on there, so I'm not going to mess with them. First, I'm working on this set of points on the left side. There's 2 screws back here that hold the hinge on. But first I'm going to relieve some of the spring pressure. If you use a skinny screwdriver, it won't catch on the spring when you turn it. These are left-handed threads, so I'm turning counterclockwise to lower it. I'll go until I run out of threads. There's still some spring pressure on there, but less than there was. Before I do that, I'm going to check the gap. If I push down directly above the core until the points just close, there should be a 20 thousandths gap between the top plate and the core sticking out of the middle of the coil. That's not very close. I can't get the feeler gauge in there at all, so that gap's too small. I'm going to take it apart. You have to be careful. There's a wire that connects to this part, so you can't just lift it off. I'm going to move it back so I can see the point contacts. Here's the fixed contact. It looks pretty dirty. And here's the movable contact. It looks just as bad. Now I'm going to take this triangle file and start cleaning off the points. These points are surprisingly soft compared to ignition points. Don't take any more off than you have to, and try to make the face rounded like it was originally. If I turn it around and file from this side, it don't make that squeaking noise. That's due to the shape of the arm that the contact is mounted on. This one's got a little pit in it. I'm going to go until it just disappears. The top of this coil looks dirty, but I guess that's mostly discoloration. I'm going to scrape some of the corrosion off of this plate here. It might not affect the magnetism, but I can get a more accurate feeler gauge reading if it's cleaned off. Here's a close-up of the points after I'm done. Shiny and rounded. And this surface is clean for the feeler gauge. I'm ready to put this back together now. This needs to make good electrical contact, so I'm going to scrape the corrosion off of the metal where it goes together. Try to keep the top square with the bottom when you're tightening the screws. Both of the screws are in slots, so there's lots of room to get it misaligned. When you're done, the contacts should line up pretty good, and the top should spring return open when you push on it. Now to check the gap, I'm going to push down right above the center of the coil until the set of points just close. And that's when you check the gap above the coil. That gap is too small. The feeler gauge don't fit in there. Since I think the gap's too small, I'm going to verify it another way. Put the feeler gauge above the coil and squeeze it down until the gauge is pinched in there. And these points should be just touching, but there's a gap in there now. So I'm going to raise up the back end some. Well, it was not very far from the top of the slots already. I'm going to raise it up as far as it'll go and see if that's enough. Now my points don't line up very good. I need to square that up. So one of the screws is at the top of the slot, so that's as high as it'll go. Now when I pinch it down to where the points just close, this feeler gauge fits right in there easily, so the gap's a little big. That's good. If the gap was too small, I'd bend this brass arm down a little so the points touch sooner, and that would put it back into adjustment range. Now I'm going to loosen these screws and move the top down a tiny bit. Try to keep it square so the points still line up good. Now I'll pinch the center down until the points just close and check the gap. That looks good there. I got lucky and hit it pretty quickly. It's not uncommon to have to move it 4 or 5 times to get it right. And remember, that's a 20 thousandths feeler gauge. The next test is to check the points gap when it's relaxed in the open position. And that should be 20 thousandths again. That gap is too big. I'm going to use some pliers and bend that stop down so the points don't open up as far. Okay, I already bent it 4 times. I'll skip that part and just show how it ends. That's a little tight. I'm going to check it with the 18 and see if it's close. Nope, that don't fit either. Got to bend it back up a little. Now the 18 fits loose. The 19 fits pretty good. And the 20 is a little bit tight. 19 is close. I'm going to leave it there. On this dimension, if it's going to be off, I'd rather be more closed so when the coil energizes, it don't have to pull the top down as far to make the points. If the gap's too big, it's harder for the coil to pull it down. Make sure everything looks good and moves easily. I'll recheck this gap. Okay, I'm ready to see if the thing works. The power supply goes on the generator terminal and the chassis ground. The ohm meter goes on the battery terminal and the generator terminal. Voltage is going up, and it closed at 9 volts already, because I didn't raise this screw up after I put it back together. I'll turn it until the points open again. Clockwise raises it because it's a left-handed thread. Now I'll turn up the voltage some more, and it closes at 11.8 volts. I'm going to turn it up just a bit more, and that wasn't enough to open the points, so I'll take the voltage back down and try again. That looked like it was about 11 volts, but I was going too fast. I'll go back down, and it opens at around 10 volts. Yep, that closes at about 11 volts now. Even though I kept turning clockwise, the voltage went down. I think that's just the way the spring touches the screw head. So I'm going to keep turning clockwise, about a quarter of a turn. Take the voltage back down. And this time it closes at about 11.9 volts. I was going a little fast that time, so I want to try again. This time it closes at about 11.7 volts. Take the voltage down, and I went too fast to see that one. Taking the voltage back up, and it closes at 11.7. Back down, and that opens at 11.6. Back up, and it closes at 11.7. Back down, and it opens at 11.5. That works pretty well. I'll take the voltage down and try again. I'll try to bring the voltage up slowly, and it should close at about 11.7. That looks good. And they only have to come down a few tenths of a volt for it to open again. As I go up and down here, it's starting to close at a lower voltage. It's closing at about 11.5 volts now. I'm going to take the voltage back down to open the points all the way again. When I come back up, it closes at 11.8. I'm going to leave the adjustment there for a bit and do a different test. Normally what I find is when I put the cover back on, the voltage readings will drop from 0.3 to 0.5 volts. It's because of the way the metal cover changes the magnetic field. So now I need to put the cover back on and do that test again. I didn't do this on purpose, but notice right now I happen to leave the voltage on 11.4 volts. And when I put the cover over the top, the points will close, changing the meter reading. And that's only due to the way the metal cover changes the magnetic field. Now I'll go through it with the cover on. First I'll take the voltage down so the points open up all the way. Now coming back up slowly, it closes the first time at 11.4 volts. Going back down, and it opens at 11.2 volts. Going back up, it closes at 11.4 again. Back down, and it opens at 11.1. Back up, and it closes at 11.3. Back down, and it opens at 11.0. Well, that first reading wasn't much higher than the others. I'm going to take the voltage way down this time to about 5 volts. Coming back up, it closes at 11.6 or 0.7. Back down, and it opens at 10.9. Back up, and it closes at 11.0. Since I put the cover back on, the points closed first at about 11.4 to 11.6. They opened at about 10.9 to 11.2, and they closed after the first time at about 11.0 to 11.3. So there's some overlap there, probably because I'm using a digital meter. Maybe it would work better with an analog meter. Compare that to my cheat sheet, and that's pretty close to where I want to be. Here it says I like to get it between 11 and 11.5 volts, and that's where it's at. It closes at 11.5 volts, and it opens at 11 volts. I'm done with that coil, so this thing is now halfway to being functional. That's as far as I'm going this time. Next time I'll work on the second coil. Sometime after that in this series, I'll talk about what each coil does and why I set them up like that. Alright, that's it.